4.8, analyzing graphs of polynomial functions. We'll start with just a problem. F of x equals x to the fourth minus 5x squared minus 3, and we'll answer a bunch of questions. That is analyzing this polynomial function. So the first thing is find the y-intercept. So we could do a lot of this stuff analytically, but we're going to lean on our calculator to do it. So here's our equation. I'm going to graph it. And we're trying to find the y-intercept to start with. So the y-intercept, where it crosses the y-axis, it can only have one answer. It's right there. So we can calculate value 0, and that'll always tell us our y-intercept. You can see it's 0, negative 3. So our y-intercept is 0, negative 3. Find the x-intercept, or intercepts. Well, it looks like it has two x-intercepts, so those are zeros. So calculate the 0. Do that 2 times. So left bound right here, right bound, and then guess, and it's 2.35. And it says negative 1e to the negative 12, so that's 0.000000. Okay, so 12 and then 0. So basically that is 0. The calculator is rounding it off. So it's 2.35 comma 0. That's one x-intercept. Calculate the 0. Go on the left side of it. Go on the right side of it. Guess it. And negative 2.35. So negative 2.35 and positive 2.35 comma 0. Those are your x-intercepts. So next thing is find the turning points and label them as local mins or maxes. So turning points where it changes direction. So it's decreasing until it gets to right there. There's a turning point. And then it increases, gets to right there. That's another turning point. And then it decreases to right here. That's another turning point. And then it increases forever. Okay, so we have 3 different turning points. These 2 down here are the minimums. So relative to all points around there, it's like the lowest point. So that's a minimum, and that's a minimum. They're called local because it's local to that area. It's a minimum. Like right here is a maximum, and it's a local maximum. It's not the highest the graph could ever be. It goes up forever and up forever over there. But locally, that is a maximum. It's a peak, a local peak, a local min, local min. Okay, so we can find those by calculating minimum. We'll do that first. One right down here. Negative 1.58 comma negative 9.25. So negative 1.58 comma negative 9.25, and that would be a local minimum. There's a max. We'll do that next. So we're going to calculate the maximum, left bound, right bound, guess, 1.46 e to the negative 6, so that is 0, 0, negative 3, so 0, negative 3, that is a local max. And our last turning point is right down there. If it's symmetrical, I'm guessing it's going to be positive 1.58 comma negative 9.25. So we'll see if that's true. Left bound, right bound, guess 1.58, negative 9.25. 1.58, negative 9.25, and that is a local minimum because it's the lowest point around there. So where is f of x increasing and decreasing? Well, it increases between a minimum and a max, and it decreases from a maximum to a min. So you can see that it's decreasing here. Did it show up at all in the video? Not really. Not worth doing, I guess. So it decreases until it gets to there, and then it decreases from here to here. Okay, so it increases from here to here and then here to here. So let's do increasing first. So what's the x value right here? Well, the x value is negative 1.58. So it increases from negative 1.58 to 0. Remember, when we're talking about increasing or decreasing, we're only talking about what are the x values in those intervals. So it's what's the x value right here? Like from here to here is where it's going to increase. So from negative 1.58 to 0. And then it's going to increase from here to here, which is positive 1.58 to infinity. So we could say 1.58 x is greater than 1.58 to infinity, or just say x is greater than 1.58. Some people like to write it as x is greater than 1.58. Whatever, these two are literally the same thing, so whatever you prefer. I think most students actually prefer this, but that's where it's increasing. It decreases from all the way to here, which is negative 1.58. So for x less than negative 1.58, it's decreasing, and then between 0 and 1.58 it decreases. So between 0 and 1.58 it decreases. These are all the x values in the interval.